Okay, let's take a look at one more example from 6.5 using the central limit theorem. So number 14 says manhole covers have these requirements. Assume that a manhole is constructed to have a circular opening with a diameter of 22 inches. So men have shoulder breadths that are normally distributed with a mean of 18.2, standard deviation of 1. The first question, again, is not a central limit theorem question. It just says what percentage of men will fit into the manhole. So individual people, just one at a time. So let's take a look at the curve. Should look like this. Shoulder breadths have a mean of 18.2. Standard deviation is 1. And so let's see, the question is what percentage of men will fit into this manhole, which is 22 inches. So this time, I mean, it looks like that's basically everybody, but let's figure that out. So we need to turn 22 into a z-score. Fortunately, that's not too hard. 22 minus 18.2 divided by 1. That's 3.8 divided by 1, which is just 3.8. Okay, so we just need to know what percentage of a normal curve is less than 3.8. So stat disk can do that for us. Let's see, stat disk 3.8, and that's 0.9999. So basically, almost everybody. So 99.99% of men will fit into this manhole. Okay, so now the question moves on to Connecticut Light and Power. They've got 36 men that work for them. So the question is, if 36 men are randomly selected, what's the probability that their mean will be less than 18.5? And the idea, or what Connecticut Light and Power is thinking, is maybe we can save some money if we make our manholes smaller. Okay, so let's look at the probability of a group of 36 having a group average that's less than 18.5. So let's draw a picture again. The mean is still 18.2. Standard deviation has changed, though. It's not 1 anymore. It's 1 divided by 36. 1 divided by the square root of 36, which happens to be the square root of 36 is 6. So the standard deviation is 1/6 now. And we're wanting less than 18.5. So 18.2, 18.5. I don't really know where 18.5 is scale-wise, but I know it's to the right of 18.2. So I'm trying to find that area right there. And so we just need a z-score for 18.5. So that'll be 18.5 minus 18.2 divided by 1/6 this time rather than 1. So that'll be 0.3 divided by 1/6. And let's see if I could grab the calculator at this point. Nothing wrong with that. But dividing by a fraction means flip and multiply. So 0.3 times 6. Is 1.8. So we've got a standard deviation of 1.8 now. And let's see. So now we just need, not a standard deviation, a z-score. Z-score of 1.8. So we need the percentage of the curve that's less than a z-score of 1.8. So 1.8. And again, that's pretty good percentage of the curve. That's 0.9641. So this area right here was 0.9641. And Connecticut Light and Power might want to say, well, hey, there's a 96% chance that our 36 guys will have an average that fits through a smaller manhole. So why don't we make them smaller? And hopefully you will go back to them. This is why they put these thought questions in the book. Hopefully you'll go back to Connecticut Light and Power and say, it's not the average of 36 guys that has to go through this manhole. It's each individual guy that has to go through the manhole. Sometimes it's appropriate to talk about the average. Like there's a different problem in the homework where you talk about the elevator, and it doesn't matter if one person on the elevator is super heavy, as long as the average weight of all the people on the elevator is not too heavy. But that's not the case here. This is just individual people have to get through this manhole. So this probability of the average of 36 people getting through the manhole doesn't apply in this particular case. The reason they're asking this is as we go forward and use the central limit theorem, they don't want you to use it blindly. They want you to think about whether or not it applies in a particular situation. All right, tackle that homework. Let me know if you have any questions.